Good morning, everyone. Today I'm here to present about our paper, Temporal Embeddings and Transformer Models for Narrative Text Understanding. My co-authors are Simone, Mellace and Alessandro Antonucci. We are from the Artificial Intelligence Lab, ITSIA, Switzerland. Today the main topic and the focus is how to apply artificial intelligence techniques in narrative text understanding. We all know that the state-of-the-art deep learning models were successfully applied to different domains such as biomedical sector, financial sector, and fraud detection, hate speech detection, etc. very successfully in the recent years. And deep learning is of course boosting the field of natural language processing, text mining applications, and so on. So today the focus is the specific subdomain of narrative text understanding, that is the literary text mining, how to apply such artificial intelligence techniques in literary text mining. One of the main challenges in literary text is the inherent and intricate nature of the language richness, the lexical diversity and style variances which is involved in the literary text. So in this paper, we mainly focus on how we can apply the deep learning models in understanding the various contents of the literary text. So our focus is to identify the character relationships using supervised and unsupervised deep learning techniques. In the supervised approach, we experimented a BERT classification model, and in unsupervised approach, we used this for learning the dynamic evolution of the characters in the literary text, such as a novel or story. And of course, these two approaches are complementary. They can be used together also to produce a more integrated approach. So in both these approaches, the first step is of course pre-processing. So in any novel or story, the main entities are the characters. So first step is character recognition. And for identifying or recognizing the characters, we used a standard named entity recognition algorithm using the Stanford NER tool. On the top of that, in order to impose some peculiarities of the literary text, we used the DB scan algorithm, because for a novel, we know the characters can have different aliases. So for example, in the Harry Potter series, the character Ronald Weasley is also termed as Ron Weasley, and so on. So first step is using the DB scan algorithm, we performed a character clustering to perform the character de-aliasing. And the distance metric used is a fuzzy-wuzzy string similarity metric. So once the character identification phase is done, we already know what are the characters or entities in the text. Now how to use the different approaches to understand the character clusters or character evolution and character relationship within a novel. In the unsupervised approach, our main intention was to identify the character trajectories or evolution of the characters over time by using temporal word embeddings. We all know that in general, embeddings map words or phrases to real valued vectors, and they can encapsulate contextual information and some semantics of the word. And one of the main word embedding model is word-to-vec, which constructs the embedding using a continuous bag of word or scriptgram approach. Now, this is like a static embedding. In order to study the dynamic evolution of the words, or for example, the semantic shift of the word, we need something which spans over time. So that is temporal word embedding. So there are word embeddings which is trained or which is modeled over different time slices or time spans. So in the given figure, we are showing the use of how we can use temporal word embeddings for the semantic shift detection. So for example, this is one of the common example used. So we have the word gay. and we can see the contextual words. So in the early centuries, it was more related to words like cheerful, happy, and all. And when in 2005, if you see, the clusters are more related to homosexual, lesbian, etc. So for semantic shift detection of words, temporal word embeddings are used. Also to study temporal analogies, also it's used. The same approach is adapted by us to study the dynamic evolution of the characters. So in this approach, we are training the embeddings over different time slices or time periods. So when the embeddings are trained independently, one of the problem is they cannot be compared. So the alignment problem is there. In order to overcome this issue, an elegant method was employed by Carlo et al. The same method is utilized by us in order to derive the character trajectories. So in the method proposed by Carlo et al., a word-to-vec continuous bag of word architecture is used. We know that in this architecture, given the contextual words as input, the target word is predicted. So in this method, first a static embedding is trained by ignoring the temporal interval. So without considering the time slices, we train a static embedding which spans over the entire text. For example, if it's a novel, we train an embedding over the entire novel. And then we split the novel or the text into slices or time spans and train the temporal embedding, or we say dynamic or diachronic embedding, over each time slices, but by keeping the target embedding matrix as frozen. So for example, if W is the atemporal context embedding matrix and W dash represents the atemporal target embedding matrix, W dash will be frozen and only W will change in each time slice. So when we freeze the target embedding matrix and only allow the contextual input weight matrices to change, it is proved that we can compare these dynamic embeddings. They become comparable. So this approach is used by us also in order to identify the character trajectories. So experimental analysis was done on the two main novels. One of the two main novels, one is Little Woman by L.M. Elcourt and other one is the first 6 books of Harry Potter series by J.K. Rowling. So in this figure, you can see the trajectories obtained with the temporal word embedding on the Harry Potter series. We have on the given representation the character trajectories for the 3 main characters in the book with reference to the main character, that is Harry. So with reference to Harry, we computed the cosine distances of the embeddings and have plotted these trajectories. So Voldemort is an antagonist, a villain character in the novel, and Hermione and Ron are more close to Harry. They are good friends. So if you see the character trajectory or the character plot evolution, you can see that Hermione and Ron are close, and if we consider the x-axis as Harry, they are close to Harry, while the Voldemort, as expected, is moving away. So it's like having different semantic spaces based on the contextual information which is being tracked by the temporal word embeddings. Now, this is a TSNE projection for the Little Woman novel. Here we have plotted the evolution of the 4 main characters, which are the 4 sisters. And in this, if you see, one of the intuition is that the 2 sisters, Amy in blue and Jo in gray, they moved out of the town and moved away from the other 2 sisters in the middle of the plot. So could be because of that their plots are a little bit different, like moving away. So such assumptions can be made from these plots, and of course, it captures some information about the characters and how the character evolves over time in the novel or in any series of book. And it also can capture some semantic clusters like villain and the good characters or the friends and enemies. Such semantic clusters can also be obtained using such embeddings. Now we are going to discuss how we use the supervised approach for character relationship extraction. So in this approach, we use the state-of-the-art BERT-based classification model, and here the problem is modeled as predicting whether a character pair is having a relationship or not. Here we have focused only on the family relationship, so whether it's a parent of relation or it's a sibling or not, and we modeled it as a simple binary classification task and used the BERT-based transformer model. Now, in the supervised approach, one of the challenges is to have a data set for training, and for literary text, such data set is rare, and also construction of such data set is of course time consuming. So we used an approach for automatic annotation of the data set. We increased the neighborhood parameter for the dbScan clustering algorithm for character clustering, which was found to be useful to cluster the characters of the same family based on their family names. And these characters in the same cluster, these character pairs were considered to be the positive samples and the remaining were considered as negative samples. So using this, we created a data set which was automatically annotated. Now, the experimental analysis. So this is the result for the Harry Potter series. So in this we use the BERT classifier model, and we applied this classifier on the 6 books of Harry Potter series by using a one held out testing, and so 5 books were used for testing and 1 was used for 5 books were used for training and 1 for testing, and using the parameters which are given here, like Adam optimizer, 10 epochs, and the learning rate of 2 into 10 raised to -5. And the average of the results over each testing is shown here, which gives an F score of about 78%, which is considerably promising, also considering that the dataset was manually annotated. And as it is a sentence level classification, we also used a majority voting scheme in order to find the final prediction for a character pair. So like we have a bag of sentences and the predictions, and we use a majority voting scheme to get the final prediction. So in this paper, we mainly exploited the use of supervised and unsupervised deep learning techniques for literary text mining. And we have seen that such methods can be, of course, used for understanding the character evolution, character relationship, and even constructing the knowledge graphs and so on. So in future, we aim to integrate such approaches and improve the approaches to build character networks, and also to derive knowledge graphs and use other DL models and compare them. Thank you.